Okay. All right, so we're going to start out with, do you agree or disagree with each of the statements, and be prepared to explain your reasoning. So let's start out with this. Employee A gets a pay raise of 50%. Employee B gets a pay raise of 45%. So, employee A gets a bigger pay raise. Do you agree or do you disagree? What do you think? Does employee A get a bigger raise? Yes or no?
Yes.
Yes, why?
Well, it's a bigger number or percentage.
It's a bigger percentage, okay? Anybody want to agree or disagree?
I agree.
You agree? Okay. Let me ask you this then. Let's say employee A makes $10 per hour. So how much does he make now? Well, let's draw it and see. So here's our X. Originally he makes 10. He's making an increase of 50%. Okay, and we want to know how much he makes. So this is 100%. This is 50%. So Y, we don't know, is 150%, which we're going to write as a decimal as 1.5, of means to multiply, times 10. So what is 1.5 times 10?
15.
$15. So now he's making $15 per hour. All right? Employee B only gets a raise of 45%. But let's say he's making $20 per hour. Okay? So we're going to do the same thing. His original is $20. He's increasing this time by 45%. This is always 100%. So we want to know what's his new pay. So Y is 1.45, that's 145%, right? Of means to multiply of 20. How much does he get paid? Take out your calculators. 1.45 times 20.
$29.
Okay, so how much more is he getting paid? He's getting paid $9 more. He's getting paid $15 more, so it works there. But what if he got paid $100 per hour? What if our original was $100? We add on 45%. Okay? And we want to know what he makes now. So Y equals 1.45 times 100. How much does he make now? He makes $145 per hour. How much increase is that? He started out at $100. Now he's got $145. How much was his raise? $45. How much was his raise? $15. So what was different? Was his original extremely higher than his original? The percentage is always based off of the original. So this would be true if their original was close to each other. But if their original is farther apart, if he makes significantly more, when we take a percentage of that, he's gonna end up with more in his raise than him. Okay? Does that make sense? All right, let's go on to the next one. So we're gonna go shopping. Shirts are on sale for 20% off. Woohoo! We like a good sale, right? You buy 2 of them. As you pay, the cashier says 20% off of each shirt. Each shirt means you get 40% off the total price. Do you agree or do you disagree? So she's saying it's 20% off of each shirt, so therefore you're gonna get 40% off total. Is that what that means? No. Why not?
Because, well, if you have like, if they're $100 shirts.
Okay.
And 20% would be different if you added them both together, 200 and then 40%.
Okay. So when they're saying 20% off of, it's important that it's off of what? It's off of the cost of each shirt, not off of the, it won't be 20% off of this shirt, 20% off of this shirt makes 40% off the total. It means it's 20% off of that original cost and 20% off of that original cost. Okay? All right, what is another way to describe a 25% increase? What would that look like? First off, let's draw what it would look like, so that'll help. Okay, an increase. Remember, an increase, X is always 100%. So an increase, am I gonna add a piece on or take a piece off? I'm gonna add a piece on. So if this is 100%, I'm adding on, and our new is this. So how would we write that? How could we describe it? What's it gonna get multiplied by? Y is, remember it's always Y is what percent of X, right? Y is what percent of X? 125% of X. Y is 125% of X. Everybody see that? Okay, how do we write 125% as a decimal? We don't know how to do that? Okay, you move the decimal point over 2 places to the left because you're dividing by 100 because percent is per 100. So that's going to be 1.25x. All right, makes sense? How about at home? Make sense? Okay, obviously I'm talking to myself. All right, so what is another way to describe a 25% decrease? Can we draw a picture again? Will that help you? All right, so 100% is always the whole thing. This is X and this is 100%, the whole thing. Okay, now we're going to decrease. Are we adding on or are we taking off? We're taking off, so I'm gonna pull this out of here and I'm gonna take off a piece, and this right here, we want a 25% decrease. That's going to go right there because that's what's taken off. So what is Y? What's this piece right here gonna be? 75%. So Y is 75% of X. So how would I write that as an equation? Y is means equal 75% as a decimal is 0.75. We did this on Tuesday. Remember we made that big table? Okay, 75% of means to multiply x. All right, questions? Are we seeing how we do percent increase and percent decrease? Yes?
Yes.
Okay. So a percent increase means 100% plus 25%. So that would be 125%, which we would write as 1.25 as a decimal. Decrease would be 100% minus 25%, which would give us 75%, which we would write as a decimal 0.75. Okay? All right. When a quantity is increased or decreased, what percent describes the original or starting value? The original is always what percent? 100%.
100.
X is always the original and it's always 100%. You probably want to write that down somewhere. X is always the original 100%. Okay, Y is the new. So you may want to think, I'd probably write this down somewhere. Y is what percent of X? Y is the new. The new equals the percent times the original. Remember, X is always the original. So whenever you're writing an equation, that's what you're going to write. That's what you're going to think. That's how you make up the equation from the tape diagram. You start from the bottom and you go up. Okay? You got that written down?
Yep.
All right. So the original starting value is always 100%. So what strategies have we used to help us calculate percent increase and decrease? Well, we can use a table, we can use an equation, we can use a tape diagram, and we can use a double number line, which we're going to work on. Okay? All right, for each diagram, this is the first practice problem. For each diagram, decide if Y is an increase or a decrease relative to X. Okay, is Y, yes ma'am? Yeah. Is Y an increase or a decrease to X? Well, X is this whole thing. Is Y bigger or smaller? Smaller, so would that be an increase or a decrease? That's going to be a decrease. Can you tell me by what percent it's decreasing by? 25%, because each one of these is 1/4, which is 25%. Going back to what we did on Tuesday, this is Y is 3/4 of X, right? Okay, or 0.75 of X, or 75% of X. So the decrease is 25%. All right, is B an increase or a decrease? It's an increase. We add on one, right? Okay, how much did we add on?
25%.
We added 25%. So Y is 125% of X. Okay, see the difference between the two. Y is 125% of X. This one, Y is 75% of X. Okay? Questions? No questions? All right. On to the next one. I didn't mean to do that. Draw diagrams to represent the following situations. The amount of flour that the bakery used this month was a 40% increase relative to last month. All right, what does an increase look like? Am I adding on to X or am I taking away from X? I'm adding on to X. X is always what percent? 100%. It's always our original. So use this month was a 40% increase. So this is 100%. So I'm adding on a piece that is 40%. And this is going to be our new, which is Y. Okay, that's what the tape diagram would look like. If we were asked to write the equation, Y is what percent? 140% of X. Y is 140% written as a decimal is 1.4. Of means to multiply of X. There's our equation. Is that in the form of Y equals KX? Are these proportional? Okay. Questions on that? All right, let's look at B. The amount of milk that the bakery used this month was a 75% decrease relative to last month. Is that going to be a percent of increase or a percent of decrease? Decrease. Okay, so here's X. X is always 100%, and we're doing a decrease, so we're going to take off a piece, and that decrease was 75%. So Y is now 25%. Does that make sense? So what would the equation be? Y is what percent? 25% of X. Y is 25%, we write it as a decimal, of means to multiply X. That would be the equation if they asked us for it, which they didn't, but that's okay. And we can go back to what we had before and think of it as fractions, but now we're going to be talking about percentages, okay? Questions? Can I raise? Who needs more time? All right. Write each percent increase or decrease as a percentage of the original amount. The first one is done for you. So this year there was 40% more snow than last year. And they said the amount of snow this year is 140% of the amount of snow last year. Why is it 140%? We added 40%, and remember the original is always what percent? 100, okay? This year there were 25 fewer sunny days than last year. Is that an increase or a decrease? Decrease, okay? So this year, so the number of sunny days this year is what percent of last year? 75% of last year. Okay. Questions on how Thomas got 75%? Can somebody explain how Thomas got 75%? Where did the 75 come from? What's the original amount? What's the original percent? 100%. Did we increase or decrease by 25?
Decrease.
And decrease means to subtract, right? So what's 100 minus 25? 75. Okay, that's where the 75% came from. Compared to last month, there was a 50% increase in the number of houses sold this month. So what's the new percentage? The number of houses sold is what percent of the original?
50%
50%
more.
more, and what percent would that be?
150.
150% of last month. Because we always start with 100%, that's our original, and he said more, so that means we're adding on 50%. All right, the runner's time to complete this marathon was 10% less than the time to complete the last marathon. Okay, percent of increase or percent of decrease?
Decrease.
All right, so the runner's time is now what? What percent of the original? 90% of his last marathon. Where did the 90 come from?
10% less of 100.
10% less of 100 is 90%. Good, Thomas. Questions on that? We always express the new in terms of the original. And the original is always 100%, and that's always X. Can I erase? Who needs more time? Okay. The graph shows the relationship between the diameter down here and the circumference here with the point 1 comma pi. If the diameter is 1, what is the circumference? Pi, right? Because isn't circumference pi d? Okay. They want us to find 3 more points on the line. So if the diameter is 2, what is the circumference going to be? How do you find circumference?
Diameter times pi.
All right, so diameter times pi would be what? If this is 2 is the diameter, wouldn't this be 2 pi?
Yeah.
Okay, or 6.28 about? And is that approximately where I'm at? Yeah. Okay, what about 3? What if I said the diameter was 3? What's the circumference going to be?
9.42.
9.42. You did that by taking 3.14 times 3, right? Is that approximately where I'm at? Yep. We could have also said it's exactly 3 pi, but that's okay. All right, we need one more. What do you want to do? 6? Or you want to do 5? Let's do 5. Ooh. 5 looks like it runs off the thing. Let's do 4 then. Okay, 4 is about right here. So 4, and remember circumference is pi d, and diameter is 4, so 4 times pi is 4 times 3 plus a little bit more, right? So that's going to be 12 point something. So is that about where we're at? If we wanted to say exactly, it would be 4 pi. Is there a reason why you're not writing any of this down, Lee? You don't want to turn it in? Okay, questions? That's review. All right, who needs more time? Okay. Priya bought X grams of flour. Claire bought 3/8 more than that. Select all the equations that represent the relationship between the amount of flour that Priya bought, X, and the amount of flour Claire bought, Y. I'm going to do a tape diagram. This is X, and X is Priya. What am I going to split this up into?
8.
Eighths. Three, 4, 5, 6, 7, 8. Okay, Claire bought 3/8 more. Is that an increase or a decrease?
Increase.
An increase. So I'm going to add on 1, 2, 3 more. So she is down here. Okay. Y is 3/8 of X. Is that what that says? 3/8 would only be that, right? Is Claire 3/8 of X, of Priya? No, Claire's this whole thing, isn't she? So that doesn't work. Y is 5/8 X. Y is 5/8 X. Is that true? No. Y equals X plus 3/8 X. Is that true? X plus 3/8 of X. Is that true? Yes. Y is X minus 3/8 X. No, that would be a decrease, right? Okay. Y is 11/8 X. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that true? Yes. Okay, so C and E are true. Did the picture help you see that? And draw the picture. Tape diagrams are a wonderful thing. All right, who needs more time? All right. I believe this is the last one. Here are recipes for 2 different banana cakes. Information for the first recipe is shown in the table. And then in the second one, we have a relationship of Y equals 7/4 X, where X is sugar and Y is flour. So Y is flour and X is sugar. Okay. If you used 4 cups of sugar, how much flour does each recipe need? So if I use 4 cups of sugar, how much flour would I need? How can I figure that out? What could I find? What can I find? What have we used with tables before? The COP, because it's not real easy to go here. So let's find the COP. So what is Y over X? Well, what is 3/4 divided by 1/2? 3/4 divided by 1/2. You've got calculators, let's go. You get 6/4, which reduces to 3/2. Did you get 1.5? Okay, so what am I going to do with that 3/2 or that 1.5? How am I going to figure out this over here? Do I multiply it by the COP or do I divide it by the COP? I multiply it by the COP, so I'm going to take 4 times 3/2. So I'm going to get 6 cups of flour. Okay, so this one is going to need 6 cups of flour. how am I gonna use this one to figure out how many cups of flour? Well, if Y is flour, I don't know flour, the COP here is 7/4. What do we know X is? How much sugar? 4, so we're gonna multiply this times 4. So how much flour do I need in this case? Can I cancel numerator to denominator?
Yes.
All right, so I get 1 here and 1 here. So the answer is 7/1, which is 7. So how many cups of flour do they need? 7 cups of flour for this one. For this one, I need 6 cups of flour. What is the COP for each situation? Well, this COP is 3/2 or 1.5. What's this COP? 7/4. Y equals KX. 7/4. Thank you, Thomas. Questions you have for me on that? Shouldn't be new, that's review, right? It's not going away, people. All right. Make sure you do the Google Slides for lesson 7 before tomorrow's class. I got the feeling we didn't get a whole lot of people who did lesson 6, which is why you were totally lost on how to do the tape diagrams. You've got to take responsibility for your learning. The notes I'm giving to you ahead of time. Okay, I only had 5 people submit the Google form before 8:30 this morning. That means only 5 people care about their grade, apparently. I can't do the work for you. You have to do it. You can't ask questions if you don't know what to ask, right? If you haven't reviewed the material, you don't know what to ask. All right, I will see you tomorrow on Zoom or in person if you're a Friday person. Have a good day.
I still have a question about number 1.
Okay,
I'm not very much understanding it.
all right, let's go back to number 1. Went too far. All right, X is always the original. So this is X from here to here. Is Y more than X or less than X?
Wait, what'd you say?
Is,
Sorry, you broke up.
is Y more than X or less than X? X is always 100%. Y is less, so that's a percent of decrease. And if you look at it, we decrease by how much? 1/4 or 25%. So this would be Y equals 75% X or 3/4 of X or 0.75 of X. Because we talked last week or Monday and Tuesday that this is Y is 3/4 of X. Then we learned to change 3/4 into a decimal. Y is 0.75X. And now today we were talking percentages. Y is 75% X. And notice that 75% is the same thing as 0.75, is the same thing as 3/4. They're all the same. Okay? All right, this one, is it a percent of increase or decrease? X is always 100%. Is X getting bigger or smaller? Bigger, okay? So that's gonna be 100% plus some more. How much more? 1/4, 25%. So back to where we did fractions, this would be Y equals 1, 2, 3, 4, 5/4 x. To write that as a decimal, y equals 1.25x, because 5 divided by 4 is 1.25. And as a percentage, this would be y is 125% of x. These all say the same thing, they're just in different forms. The fraction form, the decimal form, or the percent form. Does that make sense?
Yes.
Good. I must have said it slightly different and you got it. That's a good thing. Okay, any other ones you need me to go back over? All right, then
Good.
have a good day. Let's go take a mass break. Yes, you may use the restroom. Just walk down the left-hand side of the hall. Walk around. Get some blood to our brains. Walk. Move. Go. Walk. Walk. Spread out. Move around. Get some blood to your brain. Talking to myself.
Come on, start coming back, guys. Time's up. We need to start walking back this way. Let's go. David.
Bye, class. Let's go.
Everyone, let's go.
We did just one couple out here, didn't it? Yeah. All right, come on. Come on down. Let's go. Christopher, do not touch somebody with your jacket. Do not. Let's go. Stop. Christopher, stop. All right, let's go. Go tell the girls, come on.